Hello and welcome to the Ecosystem Development Hands-on Workshop for IBM BlueMix. We're going to start with an overview section which just really looks at how to position BlueMix. So if we look at the way that we've been interacting with technology, both on a personal level but also within business, you'll see that things have fundamentally changed over the last few years. With the introduction of tablets and smartphones, we're now getting accustomed to the idea of an app. If you want to do a function, we find an app that does that function. Whether it's using an app to navigate around a city when we're visiting, an app to look at personal data, whether it's in our fitness or in our daily routine, or even in business. We're all familiar now that an app will actually provide that functionality. And we're also becoming more used to an experience where all the data is integrated, the applications are intuitive, they present the data in a way that makes sense to us in the context. So customers are becoming to expect an integrated experience, and they can take that experience from the web across the devices. They can take that outside the office. They're not any longer tied to a desk. And the technology that's really making this possible is cloud. We no longer have to start creating apps from scratch. We use applications that exist to stitch together to provide new functionality. And we do this using the API economy. So data's made available via an API, and our new application takes APIs from many different sources and creates a new application combining all the functionality of those APIs. So application development is also changing. We're now looking at being able to deploy very quickly. The number of languages that we're using is changing, and the methodologies we use to define is changing. We're no longer looking at 9 or 18-month development cycles. We're looking at days or weeks. We're looking at applications that will span devices, so whether it's a tablet, whether it's a phone, whether it's a laptop or a browser. And we want a continuous experience. We don't want to have to wait months if we find a feature that is missing or it's difficult to use. And increasingly, data is being externalized via APIs. So really the developer wants to focus on the code. They don't want to focus on managing the infrastructure that they need to be able to do the development work. So let's just have a look at how things have changed. When we look at what we may call traditional IT, the customer was responsible for managing the entire stack. So they had full control of the entire stack. They could define it, they could customize it. There are very few limitations. However, this did take time to set up and deploy. Maintenance and upgrade can be a costly operation, and that covers both hardware and software. So typically you've got a higher costs. A few years ago we started seeing the cloud being introduced as an infrastructure as a service. So no longer did a customer have to go and buy a physical computer. They could go and rent computing power by the hour or by the month. But they still had to look at the upper layers. They are still responsible for sometimes the operating system, certainly the middleware and the runtime and the data. So they still have to manage that infrastructure, but it means that they've now takes minutes to give them a new environment where they can start doing that. And IBM's offering in this space is SoftLayer. So on SoftLayer we can rent either a virtual machine. We've got various levels where you can get private instances right the way down to bare metal. So you can choose to have a virtualization layer of your choice or even no virtualization. And there's a wide range of networking options, storage options to go along with that. So here we're starting to see standardization come in. We've got faster time to value, and some of the costs are being removed by the service provider. And then what we're seeing now is sort of the new kid on the block, which is platform as a service. This is where the service provider is taking away a lot of that management of the infrastructure, and they're providing right the way up to the runtime. So as a developer, we're only really interested in code and data, and same with operations. The service provider is giving you a managed service right the way up to the runtime for your application. So again, this really now is taking the costs lower, very fast time to value. But for us developers, it means that we have to work in a new way. We've now got a standard environment that we have to work to. We can no longer specify how we want the middleware installed. We can no longer specify how we want the OS installed. We've got some limitations that we have to be aware of and work within. And as we go through the rest of the workshop, we'll be talking about some of these limitations and the new methodologies, the new ideas, the new best practices that us as developers need to take on board to be able to get the most out of platform as a service. And IBM's offering in this space is Bluemix, and that's what we're going to be talking around for the rest of the workshop. However, it's important to realize that we're not starting with a greenfield site. There will be applications running on traditional IT within a customer's data center. They may have applications running within a cloud on an infrastructure as a service, and we may be looking to put new applications on a platform as a service. So there has to be some form of integration, this hybrid model, where we can leverage all of the assets, all of the data that lives elsewhere, and bring it into our new applications that we create on IBM Bluemix. So let's look a little bit at what Bluemix offers. First of all, it's an open standard. It's built on Cloud Foundry, which is an open standard platform as a service, and it allows you to go live in seconds. So as we'll see as we work through the workshop, you'll be able to deploy new runtimes in a matter of seconds. We've got a catalog of services that provide APIs and functionality. So you can leverage those services, give you that functionality instantly. We do have some capability to allow you to integrate to on-premise. So you can then pull in data from the on-premise. But Bluemix also gives you that DevOps. So built into Bluemix is integration with DevOps services for Bluemix. So this is an environment that gives you the ability to develop, to plan, to monitor, to deploy your application all from within the cloud environment. Obviously, security on any cloud platform is important, and Bluemix runs on top of IBM SoftLayer. So we've got all of the tried and tested security, the layers from physical right the way up to ensure that we have a secure platform. And pricing, we've got a number of different options, and as we go into the next section, I'll show you where you can find all the pricing information. So very quickly, if we look at how Bluemix works, so we've deployed Cloud Foundry on top of SoftLayer, and then we've added some additional capabilities, and that's what Bluemix is. So we've got a number of different runtimes. You as a developer are going to run your apps within IBM Bluemix. You're going to be accessing services that come from IBM or from our partners that provide their services through IBM Bluemix, or even some community open source services that we've deployed within Bluemix. Your code may have to talk to other clouds via APIs, so social media, other services that are provided by providers running on clouds outside of Bluemix, and that's okay. And you may have to go back to systems running within your data center or your customers' data centers. So this is really what we're going to be looking at for the rest of the workshop. And for you as a developer, you're going to find that you can go from having nothing to actually run your code in a matter of minutes. We're going to take away all of the hassle of having to set up a development environment, having to set up a runtime environment to test your code. We're going to show you how you can adopt continuous delivery and to automate the development and delivery of your application, and also how you can extend existing investments in IT. So not to throw away what you've got running elsewhere, but how you can leverage that and add value to that by creating applications on Bluemix that connect securely to your on-premise infrastructure. So we've been running in beta for quite a while before we went GA, and we found that certain use cases gave greater value. So we've got the web applications, we've got mobile backend, and we've got the APIs and on-premise integration, and then the analytics and reporting. And a common feature of these is really that we're extending capability from other data sources. So they're not necessarily standalone applications. They're applications that pull data from elsewhere, but add value to that data and allow users to access it in new, exciting ways that allow them to add value to their businesses. So now we're going to actually switch and have a look at Bluemix. So if I switch to a browser, you can see you can get to Bluemix, Bluemix.net, and then you've got your menu appear. Just one point, if you are in a smaller screen layout, then the menu vanishes and it's available on this little drop down here. So if you're in small display, you may have to click here to get your login button. If you're in a larger display, you'll actually see it in this corner. So we're just going to log into Bluemix. If you completed the prerequisites, you'll have an account. So just enter the email and password and then hit sign in. And this is going to take you to your dashboard screen. Okay, here it is. So first thing it tells you is if you're in a trial, how many days you've got left. And then you've got your main menu across the top here. You've got your key status area, which shows you how much memory, how many services you've got, and the application health. You've got your organization menu down here, which I'll talk about in a little bit. And then just to let you know, you can actually have two different views. If I switch to a different area, you can see this better. So you've got two different views here. If you're on a smaller display, this one can be slightly easier, or if you've got the grid display here. So if we just move over here, you'll see that I've got an organization here, and I can actually change to a different organization. So the idea of an organization is that's the top level for a user account. So all of the resources you have within your account belong to the organization. And it's up to you how you want to split that out into what are called spaces. So here I've got 4 spaces. And the resources available to the organization, I can decide how I want to use them within these spaces. My account can be assigned to multiple organizations. So here that somebody else has invited me to use part of their organization. And down I can then go to manage organizations. So typically when you sign up for Bluemix, you get an organization, which is the same as your email address. And once you have that organization, you can then create spaces. So a space is really just a way of you organizing your work within your Bluemix account. So within a space, I can decide to add users. So if I want to collaborate with different people, I can add users to this space and I can give them permissions within this space. So it means that I can have one user that can access this space but not access any of my other spaces. So if I want to invite a user, I simply come into here and I'll have the invite user. I just fill in the details there and then just select where I want them to be able to do. One thing to note is if you invite them into your organization, they're going to use your resources. So if you're outside your free trial and you have a credit card, they could be spending your money. If you're still in the free trial, they could be consuming your resources. I can also bring custom domains. Obviously, everything we do within BlueMix by default will have a system domain of mybluemix.net. Obviously, if I want to go into production, I may want to use my own company domain. So I can actually add domains in here, and then I can add certificates so they get a valid SSL certificate in their browser when they actually come to my BlueMix account. And this last one will show you the different plans and quotas that you have available. I'm still in the free trial, so this is my free trial quota here. One thing to be aware of is all work you do within BlueMix happens within a space, including the dashboard. So if you go back in the dashboard, you'll see the application health here. This only refers to the applications running in this space. If I switch to a different space, you'll see that the application health is there are no applications running in this space. These two are actually global, so they reflect the account rather than the space. So that's the dashboard tab. Next, we're going to look at the pricing tab. So this is where you go and find out information about what BlueMix is cost after you've finished your 30-day trial. So run times are charged in gigabyte hours. So if I run an application and I give it 1 gigabyte of memory for 1 hour, that's the charging unit. Services have individual price plans that are listed with the service. So I go into the pricing sheet. We can see here that this is the price. I'm in the UK, so it's giving me this in sterling, UK sterling. I can change if I want to change where I want to see the currency. So this is showing me if I want Java, Liberty, or a Node, it's going to cost me this amount of money to give it 1 gigabyte every hour. As I move into the services, you'll see that some services have different prices, different plans, and I can get all the information for all the services here, what it's going to cost me. Some are based on API calls, some are per instance deployed. Interesting thing over here is you've got an estimator, a cost estimator. So I can say, I'm going to write a new Node application. I want it to have 2 instances at 128 meg of memory. And you can see okay, it's not working. Great, but ideally this should then start populating. Here we go. A monthly charge, and it actually brings it up to a total cost up here. So you'll notice that if I have 4 instances at a quarter of a gig, or 1 instance at 1 gig, they should work out the same price. So I'm not paying by instance here, I'm actually paying by memory. So again, I can actually split this out and have 2 instances running at half a gig or 4 instances running at a quarter of a gig, and it's all the same cost. And then I can start adding in services as well. So if I want to add in a data cache, I can have 1 instance here, data cache, and that's going to then take my monthly cost up to £47.85 to run those 4 instances with a 1 gig of cache and a replica. So you can then get a good idea of what it's going to cost you to run. If you want to, at the bottom, you can switch that from a monthly cost and go to an annual cost, and that will then roll it up and show you an estimated annual cost for running that application. So that's the pricing. If you want to find anything out about Bluemix, you can switch to the document section. So you've got all the documentation here, so a bit about overview, about creating apps. So if I want to write a Java application, it'll show me all of the features supported there. The new feature pack does have some of the new beta features available. So again, you can find out all about those using the documentation. And then obviously a little bit about troubleshooting. So if you want to know about debugging, where to find information, various things about Java, Node, different applications, you can actually get quite a lot of information out of this section, the documentation section here. So if you get stuck or you think you found a problem and you want some information, the place to go is the community. So if you just go into the community, this takes you to a forum, and this is where you can find out information. So it's quite an active forum. I usually find I get an answer within 20-30 minutes. So first thing I'd normally do is search the forum to see if there is already an answer for my question. If I can't find an answer, I just simply ask a question, and that will then add that to the forum, and I can get notified. Very quickly, I can go and look at my activity, so I can see the questions that I've got outstanding, and go and find that very quickly. So that is your first port of call. If the documentation doesn't answer a question, or you have a problem, just go and ask it on the forum there. This little section is a quick start notification. So as you're doing things on Bluemix, this will often pop open, or you'll find that this is populated with context information. And then this little icon represents your account. So here you can actually go in and find out what's going on with your account. You can get all the usage information. So you can find out how much of your free resource you're using, or how much resource your different applications are using. So I get a nice little graph here. Pop-ups will tell me exactly what I'm using, and then you'll see it's broken out, so I can actually go and break it out and find exactly what I'm using down here. You can find details about your account. Obviously you can add your credit card information there if your trial has expired. So that is account. Interestingly, this is where you log out. People often lose the logout button, so this is where you go to log out if you want to leave Bluemix. So the last thing we're going to look at, which brings us into the next section, is going to be the catalog. So this is where you find how you can get starter applications, which are called boilerplates. You've got runtimes here, where you can have Java, Node, Ruby, using the Rails framework or Sinatra framework, or you can actually bring your own build pack, and we'll talk about that a little later. We've got add-ons. Add-ons are features which enhance your development environment. So things like monitoring and analytics, allow you to track and plan, so adding agile planning to your project. And also for operations, you've got things like automatic scaling, so you can scale up your application and scale down your application based on user load. And then you've got services to integrate Bluemix applications into your customers' data centers securely and reliably. Below that, we've got a number of services, and they are split up into sections. So things like using the cognitive analytics of Watson, we've got mobile, we've got web applications, data management, big data, security, analytics, and then the Internet of Things. Within each service, you'll see that they've got different color borders. The blue borders represent IBM provided services. The green borders represent our partner provided services. And then the gray borders represent community, open source community services. And for support, for the blue ones, you come to IBM. For the green ones, you typically go to the partner providing the service. And then for the grey bordered ones, you will go out to the community, the open source community that supports that initiative. And that's where you will get the best support for these different services. To find out about any of these, if you just hover over them, you've got a View More button, and that will allow you to actually go and get more information. Obviously, anything with beta in the name, it's a preview service, so maybe not production quality yet. Okay, and that's the end of this section. So now we're going to switch to section 3, and we're going to look at how you deploy an application on Bluemix. So in the catalog, you saw there were 2 sections. In the starters, one is called boilerplates. So these are sample applications that deploy a runtime and a service, one or more services, with some sample code. They really get you started very quickly and show you how you can utilize some of the services. And then within runtimes, you can see we've got a number of different runtimes available. And when you deploy a runtime from the user interface, you typically get a Hello World application, which is really a quick start application that shows you how to use that runtime. You'll notice there's also a bring your own build pack. We're going to talk a little bit more about that in a later session, but just be aware that you can't actually deploy a different build pack using the user interface. We need to use other methods that we'll talk about later. So now we're going to switch to the first exercise. So if you open up the exercise 3 PDF file and complete exercise 3A. Okay, so hopefully that went without a problem. And you managed to get your application deployed. So all you did is you went in and you selected a starter pack, the Java Cloud and Starter. Again, you can see you've got the charging information comes here. And you should just be able to deploy that. So when that was deploying, hopefully you actually noticed that you got a little prompt about the documentation. So here we are. Check out the Liberty for Java Guide to Get Started. So you can either access this by clicking this link here, or if you come into here, you'll actually see the notification. So let's just click this guide, and here we go. This is now populated that getting started. So it takes you through the steps of how you'd actually get started with a starter pack. This is using the command line, and we'll do that in the next exercise. But interestingly, this download, step 2, is where you get access to the starter application package. So what we're going to do now is switch and look at the command line. So BlueMix uses the Cloud Foundry command line. So in the prereqs, you should have gone to the Cloud Foundry command line and git site and installed the command line. When you use the command line, if you just type CF in a Windows terminal, it'll give you the help, showing you all the commands available. If you want further command for a specific item of or specific command, you just type CF help followed by the command, and that will show you all the options available for that command. So let's just go and have a quick look. So CF, and then this will give you all of the features available. Notice that for many of the options, you've got a long name, but also a shortcut. And on the slide, I actually list a lot of the shortcuts that are useful. So, for example, say we wanted to do login, we can type CF help login, and this shows you the help to actually log in with some examples here. And we're going to do that in the next exercise to show you how to use that. If you want to learn what version you've got, you can do CF-V, and that will show you the current version. My advice is keep going to the Cloud Foundry download site. They do release new versions quite frequently, and as IBM updates BlueMix, you'll find that there are sometimes some limitations. So for example, there was a recent update which required you to have at least version 6.5.1 to use all the features available within the command line utility. So just be aware of that as well. So I've listed some of the common commands that you'll use in the next few sections. So when you log in, ideally you're going to say CFL, give it the endpoint, which is BlueMix. You can leave the rest of the commands out and it will prompt you. That's a way to not put your password on the command line so it can't be seen. And then if you want to change space, if you've created more than one space, I've shown you here how you can actually see what space you're working in, but also how you can change space. So that's something you have to be aware of. Just make sure you're working on the command line. Again, everything is done within a space, so just make sure you're in the correct space. So now we're going to use the command line, and we're going to use that same application that you just deployed. You're going to download it. You're then going to do an update, and then push the update back into BlueMix. Okay, so hopefully you got the command line working and you managed to get your updated application running. So what we're going to do is look at another way of working with BlueMix. So we've worked at the command line, and now we're going to use Eclipse to write and deploy applications for BlueMix. So again, in the prerequisite for the workshop, you should have installed a version of Eclipse, either the Kepler or Luna versions, and then you should have installed the IBM BlueMix plugin. Notice there is a Cloud Foundry Eclipse plugin, but the BlueMix plugin does have some additional functionality that's not available in the Cloud Foundry. So once you've installed the plugin, it allows you to use BlueMix as a deployment target for your code, so you can write code in Eclipse and then deploy to BlueMix. So what you need to do is you actually first need to configure, and the way that you configure BlueMix is by going into the server section and configuring BlueMix as a runtime. So within Eclipse, if you just bring up the preferences, I'm aware that this is in different places on different platforms, but if you just bring up your preferences, go into server, and then runtime environments. You can define the environments here. One thing to note, again, these are space specific. So you can see that this is my test space, so if I want to add a different space, I need to add more than one definition. And important is, although you're actually using cloud resource for Eclipse, this is seen as a local server, so you must select that, otherwise you don't get the option for your next button here. And then just enter your login details. If you validate your account, just to make sure that you've typed them correctly. Just a note for anyone using the IBM internal version, you need to click the Manage Account and you need to add the Stage 1 server in there. So you need to add, and the URL is HTTPS API.stage1 and then that will allow you to actually use Eclipse with the staging environment. So on the next, it'll show you the spaces you've got on that account. You just choose which one you want it to be in and then click Finish. So this is actually now gone into the staging, the IBM internal staging server. Okay, so exercise 3C, we're going to use the same account, the same application, the Cloud and Starter application, and we're now going to work with that within Eclipse. Okay, so we've now worked with Bluemix using the web user interface, using the command line, and using Eclipse. So one thing I often get asked is, why do we need to use a command line? And the reason is that command line often allows you to work quicker, but it also allows you to integrate with other development tools where there may not be a plugin available. There's usually a scripting option, so you can run a script to actually compile or deploy an application. So you can often use a command line to actually integrate Bluemix into other development tool chains. Obviously Eclipse, it's a fairly popular development environment. So again, we can use familiar tools while harnessing Bluemix as a deployment target. And that's the end of section 3. In this section, we're actually going to talk about DevOps services for Bluemix. So there is a companion site to Bluemix called DevOps Services for Bluemix. If you've been with IBM a while, you may have known it as Jazz Hub. IBM's evolved this site into be our IBM Bluemix DevOps Services site. So this site allows you to use a web-based development environment for end-to-end development of your application. It incorporates task tracking with agile planning and source control. It integrates with IBM Bluemix, and it can automatically deploy your code. So as you check code in to the source control system, it'll automatically push that code and deploy it onto Bluemix. You've got some quality and performance monitoring tooling. And again, you can choose which bits of the site you want to use. So we don't force you to have to use all features. You can integrate it use it as a Git repository from your favorite tool, so you can work in tools like an Eclipse IDE, or you can work entirely within the browser. And like Bluemix, this site runs on SoftLayer. So the services that we've got available today are the source code management. So we've got the Git hosting. Again, if you have an alternate Git host, we can actually work with that. You don't have to do it. We've got the built-in web IDE, so you can use that to actually manage your files, change and edit your code. You've got automatic building and deploying from within the cloud. So again, you don't need to install tools to build your code on your local platform. You can do it all in the cloud. And then we've got all of the project management, planning, tracking, and team collaboration tools built in as well. So the first exercise we're going to do is to use DevOps services from Bluemix to integrate and push our sample application back into DevOps services and then work with the code there. So the last exercise shows how we can create a new project from within Bluemix. So once we have deployed a runtime or a starter, we can push that into Bluemix. But you can also create a new project from the user interface very easily. You just go from the user interface, select create new project, and then answer the questions. So from the hub.jazz.net is the URL. We just sign in. Now again, you should have signed in here from the prerequisites and use it in the last exercise. So we just log in. And then you've got the create project button here. And that's just going to ask you a few questions. You type in the name of the project. You choose what you want to use as your source code management system. Bluemix by default will use a Git repository, but we also have the Jazz source code management, or you can connect to an external Git repository. You can choose whether you want to make the project private or public. So public projects are seen by everybody, but they're not writable by everybody. So it's a very good way of making sample code available if you are releasing an API or a service that you want others to be able to use and learn about. You can add features for Scrum development, so your project planning and tracking, and then you can click if you want to deploy it to Bluemix. Again, choose the organization and the space that you want to actually deploy into. And then you just hit the create button, and that's how easy it is to create a new project. When you're in a project, it's really easy to invite other users. So if I have a project already running, and I'm just going to select this project, you just go to the overview page, as we're just loading now, and then you've got to invite others to join. If you're elsewhere within here, to get to the overview page, you usually just type the name. So for example, if I was in the edit code section and want to get back to the overview, it's very simple. All I need to do is just click the project name when this renders out. Now if I want to get back to the overview page, I simply just click there. So to invite others, just click there, and then I just put a list of email addresses separated by commas and click invite, and they'll get invites to actually come and work as part of my project. So collaboration is very simple. And similarly, when I'm working, if I choose to use the track and plan tools, the Agile process is built in, so I can work and track items using the Agile methodology. And all the tools and the dashboards are all available for me. And then again, as we mentioned before, I choose where I want the source code to be managed, whether I want to work with that code in a local IDE such as Eclipse or Visual Studio, or work using the built-in editor. So we're now going to go and work with our project in DevOps services. So DevOps services is also a great learning resource when you're using Bluemix. So many of the samples you go to on DeveloperWorks will ask you to go and find or point you to a project within DevOps services. So within the Explore tab, you've got the ability to go and find public projects. And again, there's a lot of projects there to help you find and learn about the different features, the different services available on DevOps, on Bluemix from within DevOps services. So again, if you want to share your work with others, maybe you're developing a service and you want to actually write some samples for the API, DevOps services, a public project is a good way to give people fast start for your own work. So now we're going to do the next exercise, and this time we're actually going to show how you can integrate Eclipse into DevOps services. So if you have a team, you can have some people working within DevOps services, other people working within other IDEs such as Eclipse. So we're going to show you how to integrate Eclipse with DevOps services. Okay, and the last thing I'm going to look at in this section is a project within DevOps services. So when you actually come into a project, what you normally get is an overview section here. So if you remember when you went and download the command line interface, you got all the information about the project, you got the sections all about where you can download it, find out about releases. And all that information comes from a standard file called readme.md. So if we go into the edit code section, and then we just go and look at that file, readme.md, you'll see that you get the split editor. So on the left here, this is in a format called Markdown. And on the right, this is how it's rendered. So if you want to create a heading, we can do hash when you create a project, especially a public project, you should actually go and update this readme.md format to help your users understand what this project's about and have some useful information. So what I've done in the slide is actually just put some little information about how you use the Markdown. So you can see for a header 1 or a header 2, you've got two ways of doing it. You can either put a single hash, or you can put a underline with the equal sign, or you can just use 2 hash for a second level header, followed by, or you can use a single dash for the underline. So just come down, again, we've got various ways of using lists. We can indent or nest text. You've got ways of putting break lines within the text. You can use ways of emphasizing or putting code samples in. You can put images in. Now, you just put the path of the image, so we're showing the question mark here because when I did this, those images didn't exist. Or you can put a link to another website. So these are just a few examples of how you actually do Markdown. So you can use this section as reference. Notice line spaces are a bit strange. You need 2 spaces at the end of a line to force a line break. Otherwise the line will not. So that last section just shows you that. If you don't have 2 spaces, if you just have no spaces or a single space, it will try and join lines together and flow them automatically. So what we're going to do now is just get you to play with that. So use the information in the exercise as a reference and just go and modify a README and just play around with that Markdown editor. And that's the end of section 4. In section 5, we're actually going to move from using the IBM provided applications to you writing your own applications, starting from scratch. We're also going to switch from using Java, which is a compiled language, to using Node.js, which is an interpreted language. So this uses JavaScript as a back-end language. Don't worry if you've not used Node before. All the code is provided for you, and you don't need any expertise to be able to complete the exercises. So the first thing you need to be aware of is how BlueMix configures and interacts with applications. So obviously BlueMix is managing the application and all the routing of your application, so it needs to understand where your application is actually running. So to do this, it needs to understand what port number your application is listening on. It doesn't assume that all applications listen on a specific port. What it does is it tells you what port your application needs to listen on and what host name your application should listen on. And it's your responsibility to make sure that you set your application up to listen to these. So what you need to do is you need to actually parse out these 2 environment variables, the vcap app host if you're going to set a host name, and vcap app port if you want to set your port number. Most applications tend to listen on any host name, but the important thing is that you actually specify the correct port number. And environment variables are also a way that you can actually custom configure your application. So you can provide custom environment variables as a way to configure your application. You shouldn't write files and force a redeploy of applications just to change a configuration parameter. So environment variables are the ideal way to do this. So we're going to do the first exercise here, where we're going to take a very simple Hello World application written in Node and then modify that application to actually run on BlueMix. Okay, so hopefully you found that was quite an easy exercise. And what I'm going to do now is look at some other files to help you work with BlueMix. So the first one we're going to look at is the manifest file. So this allows you to actually capture all the parameters to deploy an application on BlueMix. If a manifest file is used at deploy time, if a manifest file is found at deploy time, it's automatically used when pushing an application. And on the right here, there are some sample manifest files. If you want to find all the available options you can use within a manifest file, I've included the link to the documentation at the bottom of the slide here. I just want to point out one change that was made within Cloud Foundry as they moved from version 5 to version 6. When they had version 5, the manifest file could actually specify services to deploy alongside the application. But when they moved to version 6, they took away that ability. So within version 6, when you deploy an application, you can specify services that you want the application to bind with, and we're going to talk about services in a later section. But within version 6, you can't actually specify a service to be deployed alongside the application. So if you find some older samples, you may see services fully defined. On version 6 of Cloud Foundry, which is what Bluemix is based on, they will not work. The proviso to that is, within DevOps services, they've added that functionality back in. So if you have a manifest file on DevOps services, they will support the version 5 syntax where you can fully define a service to be deployed alongside an application. But if you want your manifest file to work on command line and within DevOps, you need to stick with the version 6 specification and only specify pre-deployed services that you want to bind with your application. So, next exercise, we're now going to introduce looking at working with Eclipse, with Node, and the additional features of the plugin. And this is one of the differences between the Cloud Foundry plugin and the IBM plugin. The IBM plugin supports both Java and Node applications, where the Cloud Foundry currently only supports Java applications. And we're also going to get the Eclipse plugin to generate the manifest file for you. So in addition to the manifest file, some runtimes require you to specify additional content. So package.json is a mandatory file required for all Node projects. It specifies, amongst other things, project dependencies. So if you have any dependencies on external packages, you specify them here. And when you deploy the application, they'll automatically be loaded into your runtime. You can also specify how to start the project, and if you're providing tests, you can also specify tests to run. So for package.json, the only mandatory fields are the name and the version. Again, I provided the link here if you want to see all of the detail. And just be aware that some other build packs have some similar things. So for example, if you're deploying a Ruby file, you typically have a gem file to actually specify the requirements, etc. So we're now going to move on to exercise 5C. And this time we're going to switch and use Node with DevOps services. So in the previous example using DevOps services, we had to use the advanced config because Java requires a build before we can deploy. But as Node doesn't require a build, we're going to show you how to work with an interpreted language using DevOps services, so you don't need to specify that build step. And now the last thing we're going to look at is how you can actually control what makes up your application. By default, when you push an application, the contents of the directory you're in, so the root directory and all subdirectories, are pushed to the server. But sometimes you don't want to push all of these files. And cfignore is a way to actually manage what gets sent to the server, to Bluemix, and what doesn't get sent. So it works in a similar way to gitignore. So if you're familiar with Git, the .gitignore file allows you to say files that you don't want to be under source control. The .cfignore file allows you to specify what files and directories are not part of your application. So we're just going to add a .cfignore file and just check that you get the expected behavior in exercise 5B. So just to finish off this section, when you're using Bluemix, you can use the manifest file to specify how you want to deploy your application, and this can save typing errors on the command line and also make sure that you get consistent deploys. So if you have a manifest file, you can really just do cf push from the directory and everything else will be included in your manifest file. And then you can use cfignore to actually manage what gets pushed. And I've just done a little summary for using Node here. So some sample code to specify the port and the host using environment variables. We can find out about the services that are bound to our application. Again, we're going to cover this in the next section. So this is some boilerplate just to look at how you get connection details, in this case for Postgres database. And then you can use the package.json to fully define your node environment and package requirements. So just a best practice here. When you're actually creating an application, you want to fully define the runtime environment for that. So when you define dependencies, you can put asterisks in the dependencies for versions to actually say, get me the latest version, but that's not a good practice. If there's been an update of a package that you depend on and some features have been taken out or modified, or there's been an API change, you don't want to find that out at deploy time. So by fully specifying your environment, which here includes the version of Node that you want to run against, you'll sort of prevent any unexpected surprises if there have been updates between your testing and your deployment. And we automatically pull in all of those dependencies because we run an npm install. So if you're familiar with Node, that's something you typically have to run before you deploy, because that pulls in all the dependencies and the build pack automatically runs that command as part of the deployment to Bluemix. So in this section, we're actually going to start talking about services within Bluemix. So up to now, we've been using fairly simple applications. In section 3, we use the cloud and database service. So we're now going to look at some of the services available on Bluemix and how we can use those within our own applications. So we saw in the catalog that there are a large number of services, and that is a catalog that's continuing to grow all the time. And the idea is that you can use those services without requiring you to set up, manage, operate the environment running those services. You can just deploy and bind to a service, and then you have all of the features offered by that service within your application. You can find the services available by a couple of ways. The first one that we saw before was just going into the catalog, and you can see that the services are listed by capability here. So we've got Watson, we've got mobile, etc. You can find out information just by hovering over or clicking on a service to actually find pricing and useful information, and then get links to the documentation. The other way of getting access to a service is using the command line tool. So I can just say cf marketplace, spell it right, and this will list out all of the services that are available. And there they are. And again, you get information about the plans available, and doesn't format very well, and then the description available. So there are the two ways you can find out what services are available. And then to use a service, all you need to do is bind it to your application. And again, you can do that using the web user interface, or you can use a command line here. So once you've actually bound a service to your application, Bluemix is going to add some information to an environment variable called vcapped services. And you can actually check vcapped services and see what it currently states in the user interface. So if we switch back to Bluemix, I go into my dashboard and I'll look at the Cloud and Starter application. If I go into the runtime, then down here I see the vcapped services. Now this is actually a JSON document, so I can use JSON parsers to actually access information. And you see that I'll have one section per service bound, and I typically have some information, but importantly I also have the credentials. So how do I connect to this service? And this is what I use to actually get access to the service. So for this cloud and database, I've got the user, the password, the host, the port. So all the information I need to actually connect to that database. And incidentally, we talked about user-defined variables. This is where you can actually define them on the user interface. You can sort of create your own user-defined variables here. But for services, vcapped services, this is where you can find that information. So you're now going to do an exercise where you're going to create two applications and get them to talk to each other using the MQLite service. So that is a pub/sub service available, and you're just going to integrate that into two very simple applications and just show that you can get those two applications communicating using the service. So hopefully that was quite easy to integrate those services. And what I've done here is just provided some boilerplate code. So whether you're using Node, I'll provide Ruby and Java. So the three different runtimes that we've got available on how you can actually use services from your applications and get those credentials. Just a note that the Java build pack actually automatically parses this for you and can auto configure some of the bound services. Again, that information is contained in the Bluemix document under the Liberty documentation. So it will automatically add things to your server XML file, for example, and bring in the required libraries, etc. So we've talked about how you consume services, but it's also possible to create new services for Bluemix. And there are two different sorts of services I'm going to talk about. The first one is a private service, which is only available to your organization. And what this does, it allows you to expose external servers and services that aren't available in the Bluemix catalog, but it makes them appear to your application as if they are a native Bluemix service. So when you are using those services within code, you've got a common way of accessing those services as if it was any other Bluemix service. But again, that is not on the general palette. It's only available for your organization, so any user of your organization. The other type of service is a public service. So this appears in the catalog in the marketplace for all users, and that can become an additional revenue stream. So if you have some IP, some data, or a service that could be of use to other developers in their applications, then you can generate an additional revenue stream by adding the service to Bluemix. And the way you do that is through the IBM Cloud Marketplace. So the IBM Cloud Marketplace is the one-stop shop for IBM customers to access services from IBM and from our partners on the cloud. It's not just for Bluemix, it's for SoftLayer, for Bluemix, but also for our pure application technology. So any of our cloud offerings, this is where you'd actually get that. And there is a partner portal, and I've put a link to it at the bottom here. And this is where our partners can actually work with us to actually add their solutions, and they will automatically appear in the IBM Cloud Marketplace. And if it's a Bluemix solution, they will automatically appear on the grid within the catalog on Bluemix. So if you go to this link, there is a presentation to help you get on board, find out all of the features available within here, and all the terms and conditions. So IBM.biz, new way for partner. If you're interested in becoming part of the IBM Cloud Marketplace, I recommend that you go there. So what we're going to do is show you how easy it is just to create a user-provided service. So remember, this is not going to come in the catalog for all users. This is just available for your organization, but it makes an external service appear as if it is a part of IBM Bluemix. Okay, so just to wrap up this section, to access services, you need to parse vCAP services, and that will allow your application to discover what services are bound to your application and how to get access to that service by parsing out the credentials. Bluemix allows you to extend the catalog that we provide using the IBM Cloud Marketplace, and you can also use SoftLayer to host services. So services in that marketplace don't need to be hosted on Bluemix. You can actually host them on SoftLayer as well. And then user-provided services give you a way of accessing some of your services that might be private to your organization within Bluemix. But again, only your organization can see those services. They're not available to those outside your organization. And that ends section 6. In this section, we're actually going to turn our attention onto IBM Bluemix and Cloud Foundry and just dig a little bit deeper into what's going on when we deploy an application and how that application is managed. So first of all, let's talk about what is Cloud Foundry. So it's an open platform as a service, and when Cloud Foundry was created, they actually wanted to actually support a number of different use cases. So it supports a number of different deployment options. So you can actually deploy Cloud Foundry on a single machine. So if you have a reasonable sized laptop, you can actually get Cloud Foundry running on your laptop as a micro cloud. Obviously, a number of companies have picked up Cloud Foundry, like IBM, and are now offering it as a public cloud offering. And a number of companies actually distribute Cloud Foundry technology, so people can create private cloud instances of it. Cloud Foundry doesn't mandate the use of any specific technology when creating an application running on top of its cloud. It supports multiple languages. Obviously, Bluemix supports Java, Node, and Ruby out of the box. And as we'll talk about later in this section, we'll show you how to add other languages in. We don't require any particular framework. So again, depending on what language you're using, you can use an appropriate framework to actually build your application. We have an open way of adding new services in, as we talked in the last section. So some services are provided by the platform, but again, there's an invitation for our partners to actually come and add additional services. And as I mentioned, that it will actually run on different underlying technologies and different size clouds. So if we just look a little bit about BlueMix, I mentioned in the first section that BlueMix actually runs on top of software. So IBM's Infrastructure as a Service hosts BlueMix, and within BlueMix we've got the core shown by this box, and then we have applications that can access the BlueMix core from mobile or web clients through browsers, whether you're doing application development or management of the cloud. And then we've also got command line tools and plugins to environments such as Eclipse. Within the environment, BlueMix will actually manage all of the communication routing and make sure that any request gets to the right application, and then that application can access its services. So digging a little bit deeper inside that BlueMix box, we're now going to look at what is in the Cloud Foundry kernel itself. So the Cloud Foundry contains a number of modules. So the top here is the routing. So when you deploy an application on BlueMix or Cloud Foundry, you give it a host, and then the kernel will ensure that all requests for that host are automatically routed to the right application. As we scale up and create multiple instances of an application, the routing will also automatically adjust itself and provide round-robin routing to the instances running that application. Underneath that, we've got authentication. So you can log in and authenticate yourself to the cloud platform. So obviously, IBM, we've extended the authentication to be able to plug into our partner world IBM ID mechanism. And then within the lifecycle section, there are two different modules. The cloud controller is actually what controls your application being deployed and making sure it's put onto the right execution environment and allows you to control it. So when you actually run commands from the CLI, you're actually talking to the cloud controller mostly. The health manager is responsible really for checking all of the bits of the cloud, including your applications, and making sure everything that should be running is actually running. If it finds a problem, it'll communicate with the cloud controller and make sure that the correct state is achieved. So for example, if there was a hardware failure and a number of applications instances went offline, the health manager would notice that and get those application instances redeployed on hardware that's still up and running. The next layer down is the app storage and execution. We are going to talk a little bit more about that on the next slide. But this is where your application actually runs. And when you push your application, it gets stored in a binary object store in this layer. The next layer down is the services. So this layer is responsible for getting your services and allowing your applications to bind to services and talk to services. As I mentioned, you can have various different sizes of Cloud Foundry. You can get it all running within a single machine, or you can actually scale it to run across multiple different machines. So all the different components communicate using this message bus technology. And then at the bottom, we've got the metrics collector and the log aggregator. So when you actually deploy one of your applications, you're not actually running within an isolated virtual machine. The way the Cloud Foundry works is it has a number of virtual machines, and those virtual machines are actually segmented using technology called containers. So when you deploy one of your applications, you're actually getting one of these containers within a virtual machine. And that's what gives it the ability to very, very quickly deploy your applications. So a container, the technology used in Cloud Foundry is Warden. So you can actually go and search on Warden or Linux container technology if you want to find out more. But a container is an isolated sort of bit of the virtual machine. It gets its own private file system, so it can't see the file system of other containers. So it is a sort of an isolated container within that virtual machine. And then what gets put into there is your framework, runtime, and application. So your application gets bound with a build pack, which provides the framework and the runtime. So Cloud Foundry can actually manage your application, and then it's running within the container within a virtual machine. So if we just walk through what happens when you actually push an application. So in section 3, you did a CF push on the exercise to actually deploy an application. So what happens when you actually issue that CF push command is the command line utility will actually make REST calls into Cloud Foundry or BlueMix into the Cloud Controller. And the first call it makes is create app. The Cloud Controller then stores the app metadata in the Cloud Controller database. Once you've created the app, you then start uploading the files that make up that app. So again, if you remember, that's controlled by the .cfignore. So any files in the current directory and all subdirectories that aren't in .cfignore will be uploaded. And again, they are stored in the binary object store. By default, when you do a push, your application will automatically be started. Again, in the first exercise, we put a no start option on the command line, but by default, the application will be started. And the first thing we do is we stage the application. And stage the application is really looking to create something called a droplet, which is that package that gets put into the container. So it contains the framework, the build pack or runtime, and your application. So we ask one of the droplet execution agents to actually stage the application. So at this point, this is where we would compile, this is where we'd actually run things like npm install, so pulling the requirements for an application. As we'll see later on, this is where we may actually download the build pack. So if we're using a non-installed runtime, we'd actually pull that in at this point. And then we package up your application and create a droplet. So while this is going on, all the output is automatically streamed back to your console. So all the messages you see, there's nothing actually running on your local machine, but it's all running out in the cloud, but you're getting the input. So if you've got any syntax errors, or you've got any issues, missing files, or some invalid files, this is typically where you get that information put out. Once everything's been packaged up and the droplet has been created, this archive containing all that's then stored back into the object store, and the droplet execution agent will report back to the Cloud Controller that the staging has been completed. And then depending on how many instances you've asked to be started, the Cloud Controller will talk to one or many droplet execution agents and ask them to actually run your application within a container in their virtual machine. So again, the droplet is pulled from the object store and pushed into a container, and then when that's running, the droplet execution agent will report back that the application instances are running. So that's what happens when you actually push your application into BlueMix. So you'll notice that in the examples that we've used up to now, we actually haven't explicitly told BlueMix what type of application it was. So we never actually said that in sections 3 and 4 we were using Java, and section 5 and 6 we were using Node. So what happens is, when you deploy an application, if you haven't told it what runtime to use, what build pack to use, BlueMix will actually try and find a suitable runtime. And the way it does this is the runtimes are installed, the build packs are installed into Bluemix or Cloud Foundry are given a position number. And what Cloud Foundry and Bluemix do, they go to the first build pack in position 1 and say, can you run this application? Each build pack has to have a script called detect. And that script will look at the files that have been uploaded and say, can I actually run this application? And the first runtime that actually answers that they can run this application is actually able to run the application. So that wins, that then gets to run the application. If you go through all of the installed build packs and nothing can run your application, then you get an error message. As I mentioned, build packs actually provide the framework and the runtime for your application. And you can actually control in the manifest file on the command line which build pack you actually want to run your application. So you can effectively switch off that auto detect. And if none of the installed build packs are what you want, you can actually bring your own. You can actually tell it to bring a build pack from the internet and run your application. So to do that, you use the B option on the command line or the build packs within a manifest. So if you just type CF build packs on the command line, it'll actually list all the build packs that are installed in your environment. And I ran this when I created the slides, and this is what it told me for Bluemix. So position 1 is our Liberty for Java, position 2 is our Node. So by default, it'll try and detect a Java program first, and then it'll detect a Node program, and it'll continue on until position 8. And if nothing has detected it, and then we're going to get an error saying that it doesn't know how to actually run that. So if I want to specify a build pack, I can specify an internal name. And to do that, I just use the left-hand column, the build pack name, from the CF build packs command. So here you can see I'm specifying the Node.js build pack, which is the community build pack from Cloud Foundry, rather than the SDK for Node, which is the IBM enhanced Node build pack. Alternatively, I can actually put a URL there to go and pull a build pack from the internet. So this one here is a PHP build pack if I want to run a PHP application. And if you go into the Cloud Foundry documentation, there is a list of all the build packs that they know about that you can actually use to run applications. So there are a large number of languages supported here. So what we're going to do now is do a lab where we're actually going to write a Go application. So this is using the Go language, and we're going to deploy that onto Bluemix using the Cloud Foundry Go build pack. So just to finish off this section, just a little bit about how services work within Cloud Foundry and Bluemix. So you notice on the architecture chart that it actually talked about service broker rather than services. So Cloud Foundry doesn't actually need to understand what your service does. What it needs to do is it needs to understand how to show that service in the catalog, if it has to do anything to provision or deprovision that service, and if it has to take any action when an application binds or unbinds from that service. So this capability is known as a Service Broker API within Cloud Foundry. So if you're going to create a service to add into the catalog, this is how Cloud Foundry would talk to you. You need to implement the Service Broker API. And typically that is done by a service broker application that sits between the actual service and BlueMix or Cloud Foundry. So when your application binds, the cloud controller will actually set the VCAP services environment variable for the application, and then the application talks directly to the service. So the Cloud Foundry, the cloud controller, don't actually need to know about the API offered by the service. And as you've seen, we can create and bind a service to multiple applications, and an application can be bound to multiple services. So that really ends the under the covers look at BlueMix and Cloud Foundry. So in this last section, we're going to look at some of the changes that you need to adopt when developing for cloud. As I mentioned in the opening section, if you come from a traditional IT background, you've probably learned a lot of best practices. When you move to the cloud, a lot of those best practices don't translate. So you've got to learn some new ways of doing things, some new best practices. Some of the assumptions that you can make when traditionally hosting, you need to learn the cloud works in a slightly different way. And we're going to discuss some of those issues in this section. So the first thing is how you approach building applications. So often, traditionally, you used a single sort of technology to build a monolithic application, where with cloud and with the speed that we need to achieve, we often build applications by combining pre-built services to actually create the application rather than having a single monolithic application. And there are a great number of different runtimes, services, and tools that you can use to create those applications. And part of the skill is learning to make the right choices. So when you're looking at a particular service, let's say data storage, you need to understand what are your requirements. Is speed of access more important than reliability or consistency of reads across multiple applications on multiple instances of an application? You've got to understand the service provider's offering. Is it fully fault tolerant? How do they scale? Is there a limit to scaling? So you've got to really be able to make the choices that are right for your application. So the other option with a database is to think of what type of database you want. Traditionally, you may have a database on a very large system, but when you move to the cloud, you may not have a system large enough to hold your entire database. So you have to then start looking at what are your options. There are some fairly well documented approaches. One of them may be to segment your data across multiple instances of databases. Another option, which has been used by some, is to shard the data, to split the data across multiple instances but keep the data model intact, where some records are put in one database and other records go into a different instance of a database, and you use a formula to work out where the data should live. And of course you can combine both methods to achieve the data storage that you need. But those choices have impact on the code that you write, because you no longer have all your data within a single database. The other option, of course, is you can move from a SQL database to a NoSQL database. And again, that may introduce some new challenges and some code changes to your application. So hopefully that gives you an indication on some of the sort of choices you need to start looking at and making when you switch from traditional to a cloud-based system. And again, part of the problem is when you first come to design your application, you may not know what your requirement is. And there are many instances of cloud applications suddenly taking off and having to scale massively very, very quickly. The second thing we're going to talk about is something called polyglot programming. Now that's a posh name for saying use the best tool for the job. If you look at some of the use cases for some of the successful cloud services running today, one thing that I noticed is that increasingly they're adopting this model of programming. They're not saying that their preferred development environment is Java or PHP or Node. They're actually allowing a mix, and they're saying what tool is best for this particular job. And we can look at that with something like Node. So Node is a single-threaded environment from the user's perspective, the developer's perspective, and it does handling requests and offloading that request to an I/O very, very efficiently. You can get a huge number of requests for very little resource handled. However, if you come to a large compute-intensive task, unless you handle that carefully, you can bring your entire server to a grinding halt. So it may not be the best choice of language for very compute-intensive, long-running tasks. There may be other languages that do that better. So again, don't always assume that you have to stick to the same job. If you're developing something and it becomes very tedious to actually try and do that activity in a programming language, there may be a better programming language out there. Obviously, you have to manage your environment. You can't have everything written in a different language because the maintainability and the skill base may also become a problem. So getting the right balance is something that you've got to try and achieve. And then the last thing on this chart is service composability. This is often called adopting a microservices architecture. And this is really, instead of having that big monolithic application, look at building your application as a series of small services. So if you look at how Unix, the operating system, was sort of developed, there was a sort of principle of each thing does one job, but does it very, very well, and you chain those things together to achieve bigger, more complex tasks. And in a way, that model has been very successfully shown to work in cloud environments. So that's something to think about. And again, when you're looking at this, you've got to think about the scalability of your application. So if a particular part of the application has to scale, if you've actually split that out into a separate service, you can then just scale that one particular area of your program rather than having to scale up the entire program where only one piece may need to scale. So I'd like you to sort of go off and read this article. I'm not going to go through it verbatim, but this was an article written by Kyle Brown. He works with a lot of our customers, and this is really more cloud rather than specifically Bluemix, but these are some fairly good rules that you should look at when moving to the cloud. So, for example, number one, don't code your application directly to a specific topology. In a traditional deployment, you may have created a deployment architecture. So you may have said, I'm going to have one of these nodes and two of these nodes, and your application may have had hard-coded some IP addresses or some names where other bits of the application lived. In a cloud environment, that doesn't really translate. The topology will change as you deploy it, as it grows, and that can be an inhibitor to actually a successful deployment. Don't assume local file system is permanent. In a traditional IT environment, you specify machines to do a specific task. So the machine that you run your database server on, you typically have dual or quadruple redundancy within hardware. It's a very, very resilient machine, and you do vertical scaling. So that machine is designed for the job. In cloud, we don't have that. And the normal principle is, when something fails, just bring it up on a different node. So if you want things like your local file system, and you're keeping a cache on a local file system, or even data on a local file system, on a cloud, you might find that a node will get created, used for a while, then destroyed as part of scaling, or if there's an error or a fault within one particular server, then workload will be sort of deleted off that and brought up elsewhere. So you lose the local file system. So I'll let you go through these rules. So the next thing really is just talking about the strategy for integrating with on-premise applications. A lot of businesses have existing IT systems, and they're not likely to move all those over to the cloud overnight. So as you're building new applications, the chances are you're going to have to pull data from those other applications to give your user that integrated, rich experience that they've come to expect. So learning how to access data from the cloud needs to be part of your application design. And within Bluemix, we do have a number of connectors, things like the secure connector, to allow you to actually create APIs within your data center that you can then access from Bluemix in a very secure way. So this is an example of how you can define that. And effectively you create APIs that you can then call to actually extract data from your data center. So what I want to do now is just go through very quickly an example. So imagine we have an application. It has a user interface. It could be mobile or web. It manages some data coming from other feeds. It may have to talk to a back-end server, and it has some computational tasks that it has to achieve. So one way of managing the load on this is we could just scale this application, and we could just create multiple instances of this monolithic application as the user load increases. And as it decreases, we can then obviously drop off instances. But on a cloud and in Bluemix, that may not be the most efficient way of handling this. So we look at the components, the web user interface. So obviously we could scale that up by implementing the web as a separate application. So the user interface is a separate application. And the best way of scaling that is just by deploying more instances. Obviously, we've got to look at things like sessions and state and make these stateless web containers. And then, obviously, round-robin routing is a good way to actually manage workload coming to those different application instances. Then, when we look at the feeds, typically, we may not want to scale that in the same way. So if I have a feed handler, I may get charged fees for making calls to that handler. So a more efficient way of actually sending those feeds into those different web instances might be pub/sub. So again, using the same technology you used in the services exercise, so having one feed handler, obviously depending on my application needs, if that crashed or died, could I get away with that being there for 5-10 seconds? Or would I have to have some hot standby? That's something that you can put into your application design. But the principle is, I wouldn't want to have multiple feed handlers, one per web instance. I'd want to actually be parsing those feeds once and then pushing the results into the web applications. And with this architecture, as those web instances grow and become more instances or get reduced as the load goes down, that works very well with pub/sub. So then if we look at the back end, So this might be going to your data center or to a database. And again, depending on the technology you use, there may be different scaling principles that you want to adopt. So you may be able to scale them in a round-robin way like this, or you can have more than one instance. If you go into a back-end system, you may want to put a cache in. So if that back-end system wasn't designed for the workload that you're going to introduce with a new application, you may want to put a read cache in there, so you reduce the load to your back-end system. That's also a way of achieving additional scalability. So the cache will take a lot of the pressure off the read load from the back-end system. With long-running tasks, again, this can be a problem if you have tasks that run at different lengths. So if I scale them up and do round robin, it may be that one of the task handlers develops a queue while the other one's sitting idle. So if I have a mixture of long-running and short-running tasks and give them round robin, that may not be the best option. So if you think of a queue, first in, first out, standard queuing technology, then this will even out the load. So as a task handler becomes free, it'll just get the next item off the queue. So it doesn't matter if they're a short-running or a long-running task, the task handlers will actually balance that out. And again, we can then scale up or scale down the task handlers automatically. So that just gives you some idea of some of the things that you can think about. And again, going out onto the web, there are a lot of best practices for developing and deploying applications on cloud that you can utilize rather than having to reinvent things yourselves. So these are some of the links. And again, I would recommend that you actually go and watch the video, Building Highly Scalable Applications for Bluemix. That's a really good video which goes into a lot more detail, that very quick example that I've just shown you before. And I just really want to, last thing, switch back into Bluemix and just look at the scaling options. So here we are in our Java starter application, and you can see we've got one instance running. So manually, I can very easily scale up just by doing that. So that's now starting a second instance, but this is now reconfiguring the routing as well. So as I go to the application, my requests are now going to be round-robined between the two different instances that are running. And that all happens automatically. I don't have to do anything there. So you can see we've now got two instances running. If I just click in there, you can actually see them here, that the instances are available. And again, if I want to scale down, I just set the instances to 1 and hit save. And that's going to go and throw away one of those instances. So again, I'm back to one instance running. Obviously, doing this manually isn't ideal, so what I can do is I can just go and connect an add-on, and I can choose this auto-scaling add-on. And again, this will now allow me to come in and configure the scaling policy for this application. So just waiting for this application to restage, adding in the scaling. There we go. So now when I look at the other scaling, and you get different options depending on the runtime. So what I need to do is I need to create that policy, and I can say I want a minimum of 2 instances running and a maximum of 5. I can then say what metric am I going to use to actually do my scaling. So here I've got JVM, heap, memory, or CPU, so let's select CPU, and I'm saying if the average utilization increases beyond 80%, then add an instance, and if it falls below 30%, then decrease it by an instance. And again, I can actually change the size of the window on how often I want it to look for the scale up and scale down, so I don't actually get this thrashing mechanism. So I can save that. And there we are. That is now saved. And then you'll notice it's automatically added a second instance to my application because of this policy saying minimum of 2. You can get metrics, and you can also look at the scaling history, so you can actually go and see how your application's been performing over time. So there we can actually see where we stand at the minute, and we can also look at the scaling history on here as well. So there we are, it showed that it added that instance to bring us up to 2 automatically. And there we are, we're actually running the 2 instances there.